Hi, I'm Matt, and in this video we are going to go over Le Chatelier's principle, particularly changes in temperature and pressure. If you haven't already watched my video, Le Chatelier's principle part 1, I encourage you to do that before watching this video, as I will be building on those topics. So first, let's look at changes in temperature. So just like a change in concentration, a change in temperature will cause a shift as well. The direction of the shift is determined by if it's an endothermic or an exothermic reaction. And to figure out the direction, we think of heat as a reactant or product, which, depending if it's endothermic or exothermic, depends on which side the heat will be on, and then how the reaction will shift. So before we get into Le Chatelier's principle, let's just briefly review our types of reactions. So we have exothermic. In an exothermic reaction, heat is released or it is produced in the reaction, so heat would be a product and therefore be on the right side of the equation. The endothermic reactions are opposite that. Energy is absorbed or is used up in the reaction. Therefore, it would be a reactant and would be on the left side of our equation. So let's try working through a question with an exothermic reaction first. So we have N2 plus 3H2 is at equilibrium with 2NH3 plus 91.8 kilojoules. So here, heat is a product, meaning heat was produced in the reaction. So this is an exothermic reaction. So if we increase the temperature, how would this shift? The first thing I would do is draw a seesaw, just like we did in part 1. And since heat is on the right, if we increase heat or the temperature, then we'll have a downward sloping seesaw. And to figure out the direction of the shift, we have to figure out how we can make this flat again. So we would have to increase stuff on the left side of the reaction. So this would be a left shift. Remember, if we increase something, we always shift away from it. So we increased on the right, so this would be a left shift. So if there is a left shift, how will that affect the concentration of the N2 and the 2NH3? Well, remember when we have a left shift, we favor or make more of the reactants. So here we would decrease the amount of products and make more reactants. N2 is a reactant, so its concentration will increase. And 2NH3 is a product, so its concentration will decrease if there is a left shift. So now, let's look at that reaction again, but this time we decrease the temperature. So, remember how when we decrease a species, we shift towards it. So if we decrease heat, we would shift towards the heat in the reaction. And since heat is on the right, we're shifting to the right. And what happens if we have a right shift? We make more products and less reactants. So the concentration of NH3 would increase, and the concentration of N2 and H2 would decrease. So now, let's try an endothermic reaction. So we have 12.6 kilocalories plus H2 plus I2 is at equilibrium with 2HI. Kilocalories is similar to kilojoules. They're both measures of energy. So in this reaction, heat is a reactant, meaning it is absorbed in the reaction. Hence why this is an endothermic reaction. So if we increase the temperature, how would this shift the reaction? So like always, let's draw a seesaw. Since heat is a reactant, if we increase it, we get an upward sloping seesaw. So how would we fix this? We would have to push down on the right to make it even, meaning there would be a right shift here. Remember, when we increase a species in the reaction, we're going to shift away from that. So here we increase the reactant, so we shift to the product side or the right side of the equation. So what does it mean if there's a right shift in this reaction? How will it affect the concentrations of the other species in the reaction? Well, since it's a right shift, we're going to make more products and use up more reactants. So the amount of reactants, such as I2 and H2, their concentrations will decrease, and our products, such as HI, its concentration will increase due to the right shift. So now, if the temperature was decreased with this reaction, the reverse would occur. We would have a left shift. Because remember, when we decrease the amount of a species in the reaction, we're going to shift towards that species. And temperature or energy is on the left, so we would shift to the left. This means we would create more reactants, so the concentration of I2 and H2 will increase, and then the concentrations of HI would decrease because more products are used up. Now that we've gone over changes in temperature, now let's go over changes in pressure. So it's important to note that a change in pressure will only affect equilibrium when there are gases in the reaction. If there's no gases, pressure will not affect it. And the side with more moles of gas is the one that's more affected by the change in pressure and will dictate the direction of the shift. This will make more sense when we look at an example. So here we have the example N2 plus 3H2 is at equilibrium with 2NH3. They're all gases, so this reaction will be affected by a change in pressure. But which side would be affected more? Remember, we look at the amount of moles to figure that out. On the left, we have 1 mole of N2 and 3 moles of H2. So we have 4 moles on the left, but we only have 2 moles on the right from the 2NH3. Therefore, the left side, or the reactants, will be more affected by a change in pressure. So if the left side is more affected by a change in pressure, how would an increase in pressure shift the reaction? Well, first thing, like always, is draw a seesaw. So for increasing the pressure and the reactants are more affected, we're going to have an upward sloping seesaw. So how would we correct this? By pushing more on the right, or having a right shift. Remember, if we increase something, we shift away from it. We increase the left by increasing the pressure, so you would shift to the right to counteract it. And remember, a right shift leads to an increase in the amount of product, so there will be more NH3, and a decrease in reactants, so there will be less N2 and H2. If the pressure was decreased, the reverse would occur. We would have a left shift, because the left side is more affected, so when we decrease it, we would shift towards it. And when we have a left shift, we make more reactants, so N2 and H2 would increase, and we use up more products, so the amount of NH3 would decrease. So now let's try a different example. Here we have PCl5 is at equilibrium with PCl3 and Cl2. So which side has more moles of gas? On the left, we have 1 mole from the PCl5. Then on the right, we have 2 moles, 1 mole of PCl3 and 1 mole of Cl2. Therefore, the right, or the product side, has more moles of gas. Therefore, it will be more affected by a change in pressure. So if we increase the pressure, the right side would be more affected. So let's draw a seesaw to figure out how this reaction would shift. As previously stated, the product side would increase, so we would have a downward sloping seesaw. Therefore, to correct this, we would have to push down on the left, or create a left shift. So we decrease the products, PCl3 and Cl2 would decrease, and we increase the reactants. The amount of PCl5 would increase. And like always, if we were to decrease the pressure instead of increasing it, everything would be flipped. There would be a right shift, we would make more products, and the amount of reactants would decrease. So now, just a few closing notes on changes in pressure. If we had an equal amount of moles on each side, a change in pressure will not cause a shift. So if we had 2 moles and 2 moles, and we increase the pressure, nothing would happen. Also, I'm going to restate it, if there are no gases, pressure does not affect the reaction. The last thing we should discuss is a catalyst. A catalyst will not cause a shift in equilibrium at all. The reaction will get to equilibrium faster, but nothing within the reaction will change. So now, before we do some practice questions, why would we want to cause a shift in a reaction? Like, what's the benefit of it? Well, in industry, oftenly only the products or the reactants will be favorable. So we could use multiple shifts to create more of the products or reactants. You'll see there's some pictures on the bottom. My friend and I actually took these while doing a lab. And the products were green and the reactants were blue. So you could see in the first picture on the left, the right is what we started with, and the left we got to be much more blue, or more reactants. And in the picture on the right, the test tube on the left was the light green, and that was the initial, and then on the right, my friend and I got to become a dark green, which showed that there were a lot of products there. Lastly, I provided some practice questions for you to work on to test your understanding. Questions 1 and 2 refer to changes in temperature, and question 3 involves a change in pressure. I encourage you to pause the video and try these on your own, and the answers will be provided for you on the next slide. The answers are as follows. In question 1, there would be a right shift, and the amount of products would increase. Question 2 is an exothermic reaction. Therefore, there would be a right shift, decreasing the amount of reactants. And in the third one, the right or product side had more moles, therefore increasing the pressure would cause a left shift. Hopefully you got these. If not, feel free to leave any questions you have in the comments below. Thank you so much for watching, and have a good day.